says integral of x to the 2/3 plus 3x to the 173 plus 4x squared dx. Remember, just like with derivatives, you need to simplify and rewrite if needed, right? So in this case, for example, do I need to rewrite or simplify? No. Why not? Because you already have the power as a fraction, so it's fine. This is fine. This is fine, right? Now, if you want to, only if you want to, like we did yesterday, one of the examples, we can separate everything. But if you don't want to, that's also fine. So we can solve it directly. In this case, what rule do I need to apply to solve this?
Exponent.
The one with exponent, right? Let's say the power rule of integrals, number 3. So in this case, for example here, x to the 3/3, if I find the integral of the solution.
X to the
5/3 over 5/3. Remember, what rule I'm applying? This rule. X to the n is equal to x to the n plus 1 over n plus 1 plus c. That's what I'm applying. Do I need to put plus c here? No, it's at the end. We'll be fine. Plus 3 times integral of x to the 173. Very good. Plus 4 times x squared integral x to the cube over 3. Plus c. Don't forget that. Now, can I simplify, rewrite?
Yes.
Yeah. In this case, this becomes 3/5 cubic root of x to the 5th power plus 3 over 174. Can I simplify that?
Yes. To 58.
58. Good. So x to the 54 over 58. Did you see what?
Yes.
You can divide by 3. Plus 4/3 x to the cube plus c. And that's it. That will be my answer. Okay? Questions? Yeah.
¿Puedes repetir lo que hizo en la segunda? O sea, para simplificarla.
From here to here?
No, así, en la siguiente. Ahí empieza. ¿Cómo
Ah,
es eso?
okay. Here, have 3, this in the numerator. So this is 3 times this, over 174. Need to check, is this number, can it be divided by 3? Well, yeah. How do I know that? Usually one of the rules to know you can divide by 3 is that if you add all of them and you have a multiple of 3, it can be divided by 3. For example, 1 plus 7 is 8, plus 4 is 12. You add the digits. You have 12. So it can be divided by 3. So what did I do? 3 divided by 3? 1. This one. 174 divided by 3? 15. You can do it with the calculator. So don't worry about that too much. Okay?
And then why did it become 4 3? You just multiply?
Yeah, 4 times this and this divided. I just moved the numbers. Good. Any other question? Okay.
That's the answer?
That's the answer. That's the answer. Let's try another one. What about number 6? Yeah. 6. It says integral of 1 over 1 minus 1 over 1 plus t dt. Just as you see this, there's like one big difference. You don't have x, you have t. Is there any problem with that?
No.
No. The same thing. Just be careful, because if you have t as a variable, you need to have dt also. Because if you have t and then you have dx, it means that it cannot be integrated with the rules. It's a constant. Okay, so be careful with that. The way you write stuff here. Now, can I simplify that? half. Common denominator, yeah. So it's going to be integral of, I leave the 1 here, over. Common denominator of this and this one is
1 plus t.
1 plus t. So here in the numerator for the fraction that is in the denominator is going to be 1 plus t minus 1 dt. Integral of 1 over t over 1 plus t dt. I just simplify. 1 minus 1 is 0. And at the end you have 1 plus t over t. Yeah? Is that the end of it? Can I integrate now? Sure? Listen, yesterday I didn't give you a quotient rule for integrals. It's because there is no quotient rule for integrals.
We can separate them.
But you can separate. You can separate. You need to separate. So, integral of what? 1 over t plus 1. Yeah? What did I do? Simple. Separate. Separate. Into that. Can I integrate now?
Yes.
Yeah. 1 over t integral. Excellent. Yeah. Plus 1 integral. Well, x, but it's not x, so it's t plus c. That's it. Do you agree? Careful. Remember, there is no quotient rule for integrals. There is no product rule for integrals. So you need to simplify always. Okay. Later, I see like in two weeks I think, we'll see techniques to deal with divisions. But not right now. Excellent. Let's try another one. What about 29? Yeah, exactly. In this case, for example, just like the derivatives last semester, the first step is to simplify. The good thing about this is that, well, last semester, some of you see this and then you try, okay, let's apply product rule and quotient rule. Sometimes it works, but not in this one. For integrals, there's no quotient rule. So you need to simplify. You need to simplify. So, what do I do?
39?
29, yeah.
So the fraction is simplify and separate?
Yeah. Can I read this one?
Yes.
Okay, so we have integral of x square root of x to the cube plus 4x squared cubic root of x squared minus 3x to the cube 4 root of x to the cube over 3 square root of x. Okay, what do I do first? Rewrite, yeah, we can rewrite the root, the radicals. X times x to the what?
1/3.
No.
2/3.
No. 3 halves. Remember, exponent, numerator, index, denominator, plus 4x squared times x to the 2/3 minus 3x to the cube times x to the 3/4 over 3x to the 1/2. Can I simplify further? Yeah. X times x to the 3 halves.
X 5 over 6.
5 halves. You just see what? Remember, you add exponents. 1 plus 3 halves, 5 halves. Plus 4x to the 2 plus 2 thirds, 8 thirds. Minus 3x to the 3 plus 3 fourths.
15.
How much?
15.
15 fourths. Very good. Over 3x to the 1 half. And then a little more. You can separate this divided by this, this divided by this, this divided by this. X to the 5 halves divided by 3x to the 1 half.
2x squared over 3.
X squared over 3. Or 1 third x squared. Same thing. Plus 4 thirds x to the you can use the calculator if you want.
13 sextos.
Yeah. Minus this over this, 1x to the 15 fourths minus 1 half.
13.
13 fourths. Yes. Do I need to simplify more or is that it? That's it. I can start with integration. Integral 1/3 times
X
Squared.
square now. Here over 3 plus 4 thirds x to that. How much? 1960. Minus x to that.
17/4.
Plus c. Can I simplify? Yeah. So x to the cube over 9 plus 4 thirds times this over 19/6. How much is it? What do I do? Okay. Remember, if you have a fraction in the denominator, you can always rewrite that as a reciprocal. So it will be 6 over 19 times 4 over 3. So it will be 6 times 4 will be 24. 19 times 3, 57. 6 root of x to the 19. Minus 4 over 17. 4 root of x to the 17 plus c. Do you see what happened? Can I simplify? Yeah, this one.
8
X to the cube over 9 plus, how much is it? 8, 19. Very good. That's it. ¿Y puedo aprender la verdad o tienen frío?
fuera de la zona. Dijo una más sobre la pasada.
Yeah.
El más uno, ¿por qué se volvió T ya en
Ah.
por la regla o?
Yeah, remember that was we have the addition. So you integrate this one, that's the rule. And when you have just one, the integral is the variable.
So si fuera X.
If it was x, then it would be x here. Yeah.
También esa, ¿por qué dijimos que se convertía en logaritmo natural?
1 over t, that's the rule. Ln of t. Why? Because the derivative of ln of t is 1 over t.
Profe, ¿cómo era el proceso para common factor que tuviera eso menos
Now the common denominator, well, you put a 1 here. For example, so this and this is the common denominator. And then common denominator divided by 1, 1 plus t times 1, 1 plus t. 1 plus t divided by 1 plus t is 1 times minus 1. Good. Okay. What else? Trigonometricals. Okay. Remember that last semester you also simplified missing entities, right? So this semester will be, well, the same thing. Can I erase, that one? Good. Okay, which one seems more difficult to you? 40, 39, 35? Don't tell me all of them, just one. 40?
40 or 39?
40 or 39? 40. Okay, let's do 40. 40, integral of 1 minus sine square of x cosine square of x times secant square over tangent square plus 1 dx. Okay. Try to remember. In this case, we need to use identities to simplify. Which ones? Very good. So, 1 minus sine square is? Cosine square, very good. Cosine square of x over cosine square, they're the same. We're going to cancel it. Times secant square, well, we're going to maintain it. Why? Because the one in the denominator is going to be also secant square. Okay? You may think, do I need to change this to 1 over cosine square or something? No. No, not in this case, because you can simplify directly. So, this one cancels. So what's my new integral?
1.
Yeah, integral of 1 dx. The answer is
X.
plus c. Simple then. Do you remember the formulas for identities? No? Wow. You study? Yeah, those are the formulas for math form, remember? No les garantizo que el Tiberi vaya a querer que les demos formularios de identidades, entonces yo recomendaría que se los practiquen. Las básicas por lo menos, las de Pitágoras, las recíprocas y si acaso las de par y par y de no. Suma y diferencia no creo que venga, no todavía. Es una recomendación. Digo, por si quieren, si les conviene. Okay. Questions so far? Okay. Okay, I'll do 2 more to cover all types of integrals, okay? And then you're going to work in with the activity. Let's say, for example, yeah, 39, the same as this. No, let me do another one. 11, let's do 11. No,
que apuntas?
No, 7. Number 7.
Yo tengo que...
Dx over x square root of x squared minus 4 minus 2 integral of 7 to dx dx. Okay. Remember that yesterday at the end when we saw the formulas, there were formulas for this type of integrals and this type of integrals? There is a way, there is a technique to solve them without memorizing the formula. I know that, but we haven't seen the technique yet. So you need to apply the formula directly. So in this case, for example, from the ones that I gave you yesterday, which one applies here? So the answer should be 1/4. 1/4? No. 1/2. Arcsecant of x over 2 plus c minus 2 times when you have a to the x, in this case 7 to the x. What should be the answer?
7 to the x over natural logarithm of 7.
Plus. That's it. That's it. That's if I apply the formulas directly. Sometimes you need to simplify, but not in this case, so it's fine. Yeah. Because it's a coefficient. Just like with derivatives, when you have a coefficient, you can just put it outside and that's it. Yeah, that's number 7. And last one, last type of integrals. Yes, Ellen. Ellen also. Last type of integral is that if I have, for example, ln of e to the x. Okay. ln of e to the x, for example, what do I do? Simplify how? Very good. You remember ln and e are inverse functions, so I can just cancel them. Basically, ln of e simplifies into just x, exponent, so x dx. And the answer will be? X squared over 2. X squared over 2. Very good. That's it? Do you see why it's like that? Yeah, just be careful because you could say, ln, there's a formula for that. Yeah, but you need to simplify. You can simplify, you simplify. Simplify that. Question? Yeah.
Yo no entendí cómo pasó de x sobre x a un medio de tal.
That's the formula. That's one of the formulas. There is a reason for that formula, but I cannot teach you that yet because you don't know the technique for that.
Esa no la conozco.
Yo creo que en unas 2 semanas más, cuando veamos función trigonométrica, se los voy a enseñar. Cómo llegar allá con triángulos. Es como lo que vimos el semestre pasado, con cómo derivar. ¿Te acuerdas? Derivar arseno, derivar arctangente, derivar arsecante, cómo derivarlo con el triángulo y sacar inverso, todo eso. Bueno, más o menos, ¿te acuerdas? Algo así, tiene que ver con eso. Excelente. Ya. ¿Qué pasó acá? Always. So they're inverses. E to the ln of x, ln of e. property of logarithms and exponentials, but they're inverses. Yeah.
Y siempre tenemos que poner esta cosa.
Where? This? Here?
Ajá.
Yeah.
Siempre hasta.
Until you find the answer.
Siempre que tengas un X, le pones. Profe, ¿esa fue la 30 o la 31?
Ah, no. Yeah, they're right. 31. I mean one. Good. So we covered all types. Questions about this, about integration? No? Sure? Very good. Fine then. So continue with the activity, please. You can go on first if you want to. You can ask me questions. But remember, check your formulas. Check your formulas.